Okay, right. I'm just making a quick video to go through the assignment from last week, specifically the one on arrangements. Um, so I'm just going to explain some of these questions to you. Hopefully you find it useful. So when I'm doing questions on arrangements, I like to think of it as boxes to fill, and that gives me the idea that it's a multiplicative approach. So for example, if you take your bank PIN, which is 4 numbers, I think that you've got 4 boxes to fill, and these are the possible numbers. So if you want to think about how many possible pins there are, how many options do we have for the first box? 10. For the second box, 10. Third box, 10. Fourth box, 10. And to get the total possible number of pins, we multiply. So in this case, it's going to be 10,000. To understand why you multiply, you can sort of visualize it almost like a tree diagram type thing. So when you consider the first digit, you could have a 1, a 2, a 3, a 4, and so on, 10 different options. And then if the first digit's a 1, then you can have a 1, a 2, a 3, a 4, and so on. And each of these splits into 10, then each of these ones splits into 10, then each of these ones splits into 10. And each of those is going to give you a unique pin. So you end up with 10 times 10 times 10 times 10, or 10,000 possible pins. If you change the question slightly, so let's say, for example, now you had to have 4 different numbers, then it would be 10 times 9 times 8 times 7 possible pins that have 4 different numbers. Say the first and last one had to be the same. Then it would be 10 times 10 times 10 times 1, because the last pin now has to be the same as the first one, so you only have one choice here. Say your pin was going to be a palindrome, so that's the same forwards and backwards. How many different palindromic pins are there? Well, the first number can be anything, but then the last number would have to be the same. The second number again could be anything, but now this one would have to be the same. So you end up with 100 different palindromic pins. So this is the basic idea for the task, and we'll just now talk about the questions themselves. So the first one here, cafe owner sells 10 different types of sandwich. Raheem buys a different type of sandwich on Monday, Tuesday and Wednesday. So he has 10 choices on Monday, 9 on Tuesday and 8 on Wednesday, giving him 720 possible combinations of sandwiches. Okay, question 2. So Alison, if she selects a red cube first, then she has to select a black sphere second, and if she selects a red sphere first, she has to select a black cube second, and the reverse of this would also be true. So if we think about the number of ways, she has 14 possible red cubes, followed by 8 possible black spheres, and 10 possible red spheres, followed by 12 possible black cubes. So in this case, we end up with 112 ways of doing that, 120 ways of doing this, so the total is 232 ways of doing it. Question 3 was a nice one. If 3 people give each other birthday cards, then each person's giving out 2 cards, which is 3 times 2. So if there's 5 people, each of the 5 people are going to give out 4 cards. So that's a total of 20 cards. Question 4 is a really good question. There's 16 hockey teams in a league. Each team plays 2 matches against each of the other teams. So there's 16 teams, and each team plays 15 other teams, and they play them twice. The problem with this, though, is that you're going to count each game twice, once for the home team and once for the away team. So we can divide by 2, and we can see here that the answer is that there are a total of 240 games. If you want to think of a similar question, the Premier League in football has 20 teams and it follows a similar pattern. So if you've got 20 teams and each team plays 2 matches against each of the other team, how many matches are there in total? Right, with question 5, you probably want to just sort of reason this one out. So the middle digit needs to be equal to the sum of the other 2 digits. So if you think about what the possible middle digit could be, if the middle digit can't be a 0, it could be a 1, then the other 2 digits would have to be 1 and 0, which means they would have to be that way round. So that's one way. If the middle digit was a 2, then you could have 220 or 121. So that's 2 ways. If the middle digit was a 3, you could have the following. You could have 330, 231 or 132. If the middle digit's a 4, we could have 440, we could have 242, we could have 143 or 341. That is 4 possible numbers. If the middle digit is a 5, then we could have 550, 154 and 451, 352 and 253. So that's 5 possible numbers. You might spot a bit of a pattern here. I'm just going to keep going just to be sure. So with 6, we could have 660, 561, 462, 363, 264 and 165. So we see here there are 2, 4, 6 possibilities. For 7, same way, we could start it with 7, 6, 5, 4, 3, 2 or 1. With 8, we could start it with 8, 7, 6, 5, 4, 3, 2 or 1. And with 9, we could start it with 9, 8, 7, 6, 5, 4, 3, 2 or 1. So that gives a total of 17, 24, 39, 42, 45. Okay, so question 6. Sammy's going to eat 5 sweets. There's 3 different flavours. He doesn't want to eat 2 consecutive sweets. So this way you can think about it with boxes. For the first sweet he has 3 options. Now because he can't eat the same sweet again, he only has 2 options, and then again it's only 2 options, 2 options, 2 options, and that's it. So we end up with 16 times 3, which is 48 possibilities. With question 7, well, this one's pretty straightforward. There's 5 possible gates to enter and then 4 possible gates to leave, which gives 20 ways to do it. Okay, question 8. This one's quite a bit more tricky. So I would consider the different squares in turn. So when you've got 1 by 1 square, you should see that there are 12 even 1 by 1 squares. When you have a 2 by 2 square, any 2 by 2 square is going to have 2 even numbers and 2 odd numbers. The 2 even numbers give an even total, and when you have 2 odd numbers you also get an even total. So all 2 by 2 squares will have an even total, and there's going to be 16 2 by 2 squares, because you've got 4 different 2 by 2s along the top row, starting with 1, with 2, with 3 and with 4, and again you've got 4 going down, starting with 1, 6, 11, 16, so you end up with 4 by 4, 16. Right, now with 3 by 3s it's a bit different, because some of the 3 by 3s will have 4 even and 5 odd, and some of the 3 by 3s will have 5 even and 4 odd. Only the ones with 5 even and 4 odds will have an even total. So if you look at the 3 by 3s, they need 5 even numbers. So when you look at the 3 by 3 that goes from 1 to 13, that one has 5 odd numbers. So they actually need an even number in the top left. So the 3 by 3 that starts with 2, 3, 4, 7, 8, 9, 12, 13, 14, that one would work. The one that starts with 6 would work. The one that starts with 8 would work. And the one that starts with 12 would work. So I think there's going to be 4 here that fit the bill. With 4 by 4s, a 4 by 4 is always going to have 16 numbers. Of them, 8 are going to be even and 8 are going to be odd. So that will always have an even total. So there's going to be 4 possible 4 by 4 squares. So that's from 1 to 19, from 2 to 20, from 6 to 24, and from 7 to 25. And finally the 5 by 5 square. Well, the 5 by 5 square has 13 odd numbers. So in that case, it does not have an even total. So you can see there that we end up with 36 possible squares in total. Right, question 9. This one is another tricky one. So say the taxi firm's, it definitely starts with a 3. Say the next number though is a non-3 number. Then there are 9 choices. And then for the next 4 it can either be a 3 or the number that's here. So that's 2 choices for each. So that gives us 9 times 2 to the 4, which is 144 options. Now that's only one situation, but say what if instead it started with 2 3s? Because this one we only had 9 choices, it didn't include a 3 as the second number. Well then again, now you've got 9 choices, 2, 2, 2. And so you see this one is 9 times 2 cubed, 72 possibilities. Now what if it started with 3 3s? Then again 9 choices, 2, 2. This one's 9 times 2 squared, 36. And you can see how this is going to carry on. The next one starting with 4 3s would be just 9 times 2 for 18. Starting with 5 3s would be just 9. And finally, if you just had 6 3s, that's 1. So in total, this gives 280 possibilities. Okay, and finally question 10. So again here, this one you probably want to take a logical approach. So we've got 6 fnags, which are red with 2 heads, red with 3 heads, red with 4 heads, blue with 2 heads, blue with 3 heads, blue with 4 heads. So let's just consider, let's say we want to line them up. So if we start with the one that's red with 2 heads, then the next one can't be red and it can't have 2 heads. So we've got 2 options. It can either be blue with 3 heads or blue with 4 heads. Now, let's say it's blue with 3 heads. Then it can't be blue and it can't have 3 heads. So the next one has to be red with 4 heads. Now the next one can't be red or have 4 heads, so it has to be blue with 2. Now it can't be blue, so it has to be red with 3. And that leaves us with blue with 4. Now if we just consider the other approach, red with 2, blue with 4, so the next one has to be red with 3, then the next one has to be blue with 2, then the next one has to be red with 4, and the last one here has to be blue with 3. So you see, after that first one where we had a choice, this is just, we don't have a choice about any of the others. We have to take them in this order. So what that tells us then is whichever one we start with, now here it was just, we randomly picked red with 2, but it could be anything. Whichever one we start with, there's going to be 2 possible lines and there's 6 possible starts. So there's 6 possible ones to start with, and each of them is going to give 2 possible lines. So we're going to end up with 12 different possible orders.